All right, so we're working on the second lesson in chapter 5, and a lot of it has to do with the graphing of the inverse relations and functions and all that kind of stuff. So I'm going to give you the graph, or I'll have the graphs passed out to you. But what they want you to do is focus on the functions and their inverses. It says obtain a lesson free source page. It'll have the three graphs on there. All right. So the first thing you want to do is make a graph of each inverse function. So first thing I'm going to do is I'm going to solve this algebraically. So I've got y equals 0.5x plus 3. All right, and I want the inverse of that. All right, so that means I'm going to write my x just like I did. I will subtract 3, and then I will divide by 0.5. So divided by 0.5. All right, now for graphing function or graphing, we want to do this and see if there's not an easier way to do it, easier way to see it. Instead of looking at it as a decimal, which may be easier algebraically, we'll look at it as a graph, or not as a graph, but as a fraction. So I'm just going to rewrite this as 1/2 with the x on top plus 3. Now what is the inverse of that? It's going to be negative 3. So x minus 3. I just broke my x. Then I'm going to multiply this times 2. So all of this times 2. And there's my inverse of it. Makes it a whole lot easier as far as writing it. And it'll make it a lot easier to graph it because then I can distribute this. It becomes 2x minus 6. And so now the graph that they have looks something like this. Let's see, 1, 2, 3, 4, 5 there, and then it goes 1, 2, 3, 4, 5, and it crosses at 3, and then it has a line. All right, so to graph this, I would go to negative 6, 1, 2, 3, 4, 5, 6. Then I would go up 2 over 1, 2, 3, 4, 5, up 2 over 1. The inverse is going to look something like that. It's not a very good one, but all in all, it would look something similar to that. It's not all that hard. What you're trying to look for is some patterns. What did it do? Does it have the same slope? Y-intercept. You're looking for anything that you can kind of see as a pattern. Again, it's more of this line, not so much this line. It's easier to see it on the second one. The second one gives you y equals 3x plus 2 squared minus 6. Now, the inverse, I'm going to write my x. I'm going to write it over here. All right, how would I get x by itself? I would add 6, so plus 6. Okay, then I would divide by 3. So divided by 3. Then I would do that gets rid of that. And I would do the square root. That gets rid of that. Okay, I still got, after all that, I still got an x plus 2, so I would subtract 2 minus 2. And now, you would use your graphing calculator to graph that. Okay, your first graph graph looked something like this. It went down to -6. Here's at -2, -6. So this point is -2, -6. Again, you'll have these on a sheet of paper, or should. Now, what does this look like graphed? Again, you'd put that into your graphing calculator, and you will see that it is -6, -2. Okay. Now, the question is, do you think it is just a coincidence that your x and your y on each of them are simply just flipped over? So the x becomes the y, the y becomes the x. Do you think that's a coincidence or not? So take some time to discuss that, whether or not you think it is or not. And then go on and do the third one, which you're going to have to use your calculator a lot more for. And kind of come up with some rules that you can see, some things that make sense to you, don't make sense to you. You should be able to come up with some things that you can learn about inverse functions that'll make it a little bit easier. Or just in general easier to see things. And that is really blurry over there. Alright, I'm going to try to focus this a little bit better. So we can see both sides. Alright, so that's an A. This is a B. Can't even see that. Alright, so let's see if we can make that so we can see both of them a little bit better. Alright, that's a little bit better. So if you can't see that at the beginning, sorry. But I'm not going to go back and redo it at this point. Alright, so that was 516. Now we're on problem 517. Alright, it says when you look at the graph of the function and its inverse, you can see the symmetrical relationship between the two graphs demonstrated by the line of symmetry. So your line of symmetry is where? It's where you can draw the line, fold them over, and they look the same on both sides. Okay. Find the equation for the line of symmetry in each line of symmetry for each graph. Why do you think these lines make sense as the line of symmetry between the graphs and the functions and the inverses? Okay, so look at your three graphs. Okay, kind of draw, have all three of them drawn out, traced, and then just fold your paper and find where the line of symmetry is, and then draw that line of symmetry. I'm going to do the first and second one, let you do the third one, okay? So for, this is what, 517. Okay, find the equations of the line of symmetry for each graph. Okay, what you're going to find out is for each graph, all right, you drew them, you should be able to see them, but for each graph, on all three of them, y equals x. That is the line of symmetry. Okay. Now, why does that make sense? Well, if you fold them diagonally, then they're going to match each other. Now, the book, kind of what you should get to simply is, why does that make sense? Is because if you're finding the inverses, then all you're doing is switching the places of the x and the y axis. So that's why the line of symmetry will always be this y equals x. Or, I mean, you could say x equals y if you wanted to. It's the same thing. But if you think about it, you had the one that looked like this. Okay. There's your line of symmetry. All you're doing is when you found your vertexes and everything else, so when you found your vertex of your graph that looked like this, what did you do? Well, this one was -2, 6. This one was -6, -2, or -6. all you're doing is switching your x and your y. That's why your line of symmetry is always going to be y equals x or x equals y. Same difference, okay? All right, 518. All right, the line of symmetry identified in problem 570 can be used to graph the inverse functions without creating the xy table. Okay, so they want you to graph x over 2 squared. Okay, so y equals x over 2 squared. Okay, so put that in your calculator, graph it. Okay, now I'm going to do it a little bit different, mainly because I don't have a graphing calculator with me right now. But I'm going to draw my graph. Okay. Now I already know what is my line of symmetry. It should be, if what we've proven so far continues to be true, that should be my line of symmetry. Y equals x. Okay. So when I graph this, if I want to graph it without a table, I can put it in the calculator and graph it. Well, you know what? I want to create a table. So x y, and I'm just going to start at -3, -2, -1, 0. All right, I'm sorry, this should be f of x, just to make it a little bit easier. 1, 2, and 3. So that means I'm plugging in x, and this is going to equal, or I'm sorry, x. All right, so I'm going to plug -3 in. What do I get? -3 over 2. -3/2 squared is what? Actually, never mind. I do have a calculator, so I just remembered I had it on my computer. So I'm not going to worry about creating a table since this problem is about creating it without the table. All right, so what I'm going to do is I'm simply going to plug that into y equals in my calculator. So y equals, I'm looking for, let me get it brought up on my, all right, so my trial has expired, whatever. All right, so what I'm going to do is I'm going to go to Google. I'm going to put in graph y equals, open parentheses, x divided by 2, close parentheses, raised to the second, enter. All right, so when I graph that, it gives me this right here. Okay, now what is the inverse of that? Well, y to the -1 equals, all right, well I have to find the, right my x, I have to find the square root of it, so that gets rid of that. Now multiply by 2, so that's my inverse. So the same thing, all I'm going to do is I'm going to go to Google again, I'm going to say y equals 2 square root x. And my internet's slow, so I'm waiting for it to come up. And guess what? It looks like something like this. Okay. Again, I'm not the best drawer, but you can see where it's pretty much, if you fold this over, that they're the inverses. Okay. By the way, if you are doing it in Google, the way you do that is you'd say y equals, because you can type those in easy, then you do SQRT parentheses x. So this is square root. You have to type it into the address bar or whatever. Okay. So if you do all that stuff, that's all good. But now, what they're saying is, if I took this, and before I ever did this, if I drew y equals x, and I would have folded that over, if I would have did it in a really, really dark pen or a Sharpie or something like that, that would kind of paste over to the other side, you would see that it was the same. But y'all all should be able to see that it's the same that way. But have your dotted line, draw that one. Okay, so here, let's flip over here and do it again. All right, so what they actually want you to do from the book is they wanted you to graph this one, and they wanted you to draw this. Now, if you would have taken this, folded it like so, kind of where it was, which that it did, you would have seen that it would have did something like that, which that's the inverse. Hopefully that kind of makes sense to you. If it doesn't, tomorrow I should be able to Skype with you or FaceTime with you or something when John doesn't have appointments first thing in the morning. But right now, while y'all are in class, they're probably putting him to sleep or getting ready to put him to sleep for his radiation treatment. So hopefully that kind of explains it. If it doesn't, just kind of remember to ask me about that one tomorrow. So 518 may be one to ask me about tomorrow, or keep notes of that, and Friday when I get back, ask me about that problem. All right, 519. All right, your graphing calculator can also help graph the inverse of a function. Check your inverse problem 518. The following instructions to use the inverse feature of your graphing calculator. Was the inverse of the graph you drew correct? Okay. So how do you, the TI-83, again, I've got to get mine working on my computer, or I'll grab one and show you how to do it. But I'm going to ask Ms. Terry to show y'all inverse on this, okay, how to graph it. All right, 520, we just did 520, find the inverse of the equation. Is there another way you could write it? If so, show how the two equations are the same, justify your inverse equation of the original. All right, so what they're saying is there another way that you could write x over 2 squared? Okay, well, that also equals 0.5 x squared. Okay, because remember this is 1, so 1/2, that's 1/2. How else could you write it? What's another way that you could write it? Again, there's a whole bunch of different ways you can write it, talk about it, discuss it. Kind of the book, what they're kind of looking for, that is 520. I'm going to read you what the book the answer key from the book. The book says you could write it as x equals y over 2 squared, or you could also do y equals plus or minus 2 to the square root of x. Okay. Does that make sense to you of how you could write it? How is that the same? How are all three of these? All right, so it says find the inverse. So what is the inverse of this? Okay, well, we know that y equals x over 2 squared. So the y to the -1, y to the inverse equals, I'll write my x, I have to find my square root, and then I have to multiply by 2. Okay. Now the reason why it's plus or minus is because it's, if you have this on the bottom, remember plus or minus, but most of the time you're not going to have to worry about it a whole lot because it'll kind of work itself out. But that is that way. And what do they do? What about these two? That's kind of where they're leading you to. What do they do? Well, they simply switched the x and the y is all they really did. Okay, because that's what inverse really is. It's just switching the x and the y. So that should, some of y'all that have kind of struggled up to this point, that should be a little bit shorter way to find the inverse. I don't like doing it that way because it doesn't really, there's a lot of problems it's not going to work on, or it will just confuse you more. And if you can do the whole process, then it helps a whole lot more. The next part we're going to get to is alright, so 521. Consider your equation for the inverse of y equals x over 2 squared. The one that we traditionally use, the one that we've kind of learned to use is y equals plus or minus 2 square root of x. And the one that the book, or the way that we just showed you, is just by switching x and y. So x equals y. Okay. Alright, so is this an inverse function? How can you tell? Okay, so how can you tell if these are truly inverse functions? Okay, the way that I would do it is I would put them in the calculator and see if my line of symmetry is what? What does your line of symmetry have to be? It has to be y equals x. If your line of symmetry isn't y equals x, then these are these. So this one and this one, this one and this one. If that's not your line of symmetry, then they're not inverses, okay? B says use a color to trace over the portion of your graph for which x is greater than 0, or greater than or equal to 0. Use another color to trace the inverse of only this part of y equals x over 2 squared. Is the inverse of this part of y equal a function? Okay, so what is, first of all, we're going to know what a function is. Okay, remember your function is a vertical line test. Okay, so remember our inverse, we said that it looked like this. We've been working with the same one the whole time. First off, is this a function? The answer should be no, because of the vertical line test, it fails. But if you graphed only when, let's see, they only want it when x is greater than or equal to 0, okay? So if you only do it then, is it a function? No, it's not, because everything would be graphed. So remember, this is your x and this is your y. So anytime it's greater than that, it's only on that side. Now the question is, what about when y is greater than or equal to 0? What would be graphed? In that case, only this part would be graphed, in which case it is a function, because it would pass a vertical line test. So your restriction to make this into a function is y is greater than or equal to 0. If you put that restriction on these inverses, then it makes this a true statement of the inverse of plus or minus 2 greater than or equal to x when y is greater than or equal to 0 is an inverse, or is a function. Now that is a F-U-N-C-T-I-O-N. Now that is a true statement. Okay. Any other time it's not a true statement. If this would have been x is greater than or equal to 0, it is not a true statement. That's the only time. All right. 522. All right, it says consider the function f of x. We're going to go ahead and flip over again. Okay, so consider the function f of x equals x minus 3 squared. How could you restrict the domain of f of x so the inverse will be a function? What could you do to the domain? The domain is the x or the y. Okay, remember alphabet. Domain is x. Okay, so we're dealing with the x's. Okay, if we say x has to be greater than or equal to 0 of this, not the inverse yet, but of this. Okay, so when we graph this, okay, it's going to be, so we got a plus 3, it's going to look something like this. Okay, should remember that from chapter 2, maybe 3, how to graph that. Okay, so now we're saying when x is greater than 0. Okay, so we're going to take this off, and then we're going to fold it over this line, because remember that is your magical y equals x, your inverse line. What does it look like? Okay, it should, if you do it right, look something like, roughly something like that, So, is this a function? The answer is yes. Okay, so if you're talking about it in its original state, okay, the inverse of this is what? The inverse is f -1 of x equals, let me move this over a little bit. Okay, well, we got to find the square root, and then we got to add 3. Okay, so this is the inverse function. Okay, so the restriction we would put on that would be y has to be greater than or equal to 0. Okay, and it's a function. Okay, but on this, to say x is greater than or equal to 0. Again, why do we have to say x here and y here? Why do we have to put that restriction on there? Because when it's in this state, before we make it into the inverse, okay, so it's in this state, we want to eliminate one of these sides. We could have also said less than or equal to 0, and it would have eliminated this side, and we would have kept this one. This would have changed this also to y is less than or equal to 0. As long as we cut off half of it. Okay, when it's in its original state, we cut off the x. When it's inverse, we cut off the y. But as long as we cut off half of it, then it stays a function no matter what. If we don't cut off any of it, if we don't put any restrictions on it, then it's not a function when we find the inverse. All right, 524. Use graphs to find the inverses of the following functions. Label the graphs, or label the graph of each function and the inverse with the equation. Okay, so 524a is, so a, we're going to do 5-24a. They say y equals 5x minus 2. Alright, so we're going to have to graph that. What's the easiest way to graph that? To me, the easiest way is to distribute this. So this becomes 5x minus 10. So I'm going to go to negative 10, put a dot. I'll go up 5 over 1. Alright, my magical inverse. Okay, so to me now, all I really have to do now is do this going to look something like that. My inverse function is what? Just from looking at this, okay, if I had all this drawn, this would be negative 10. Okay, so y inverse equals negative 10. Now, does this look like a slope of 5 over 1 or 1 over 5? To me, it looks like it's 1 over 5x. Okay, now let's look at this. Let's look at our original, or I really don't care which one you look at, but let's look at this. Okay, if we said to find the inverse of this, we'd say y to the negative 1 equals x. All right, looking at the original, okay, we got to divide by 5, and then we have to add 2. Okay, is that the same thing I did here? Or if I look at this one, after I distributed, I add 10, so plus 10, and then so x plus 10, and then I divide by 5, which you can see how they are the same. Does that make sense? Hopefully it does. Where did I mess up at? Or did I mess up? That's the question. Alright, so what should I have gotten? This is what, 524? Alright, this should have been copied it down wrong. Yeah, this is the inverse, so those are right. Okay. Now, what do you notice is different about this? What did I do wrong? Well, this negative 10 should have been a what? Positive 10. Okay. And then if I would have done that, I would have had my y-intercept would have been 2. Okay. And if I just would have actually done that right, I could have seen that was actually 2. Okay, because there's my y-intercept, that's what goes there. And my slope is 1 over 5, and it would have looked something similar to that. Okay, so you should be able to find inverses algebraically as well as graphically. We're going to do B, so we're going to do 524B. And then 525, I'm not going to have you, if you have time in class, I'll let you do that. But after this, you will start on those packets I gave you. Remember, it's a quiz grade. And at the end of the week, it will be a test grade. All right. So if we graph this, okay, what is it going to look like? So I'm just going to draw my graph. All right. And I don't care if you go on your calculator and you put this in your calculator. So I want to graph y equals 1 plus open parentheses 2 divided by x close parentheses. Okay, and you're going to see that it looks something like this. Okay, something close to that. Again, y'all know how great of a drawer I am, so you know that that's not a very good. But what does it look like when it is that magical y equals x? Okay. Now, this one's a little bit different because this also has one up here that kind of does the same thing. Okay, and really the only thing it changes is it just kind of changes to there and to there. Okay, it's one of those. This one's harder to see graphically. Maybe not on your graphing calculator or TI-83, but it's a lot easier to find the inverse algebraically. Okay, because you've got the x. Okay, so we're going to need to subtract 1 first. And then that 2 over 1, how do you get rid of the 2 on the top? Really, it just does this. Okay, the 2 stays on the top, to tell you the truth. We just add 1 to each side, or subtract 1 from the denominator. Okay, so now there is a way, and I'm sure some of you in class know it, that you can go and you can say, what is the equation for this line on your calculator, or the equation for this one or this one, okay? If somebody knows, I don't know how to do it, okay? So if somebody can figure out how to do that, show the class. I'll give you some bonus points or something, but figure out how to do that and show the class how to do that. Now, homework is a review preview 526 through 539. Okay. Before you get started on that, you need to work on your packet a little bit. Sub's going to take notes of who doesn't work on their packet. Remember, you get a quiz grade. So this week you'll have 4 quiz grades. Hopefully I'll be back Friday. Okay. So 100 divided by 4 equals 25. So at the end of the week, if you take a day off and don't do the packet, that's a 75 test grade. So your options are 75, 100, 75, 50, and 25, and 0. Okay, depending on how many of those 4 days you work on your packet. Again, hopefully I'll be back Friday. If you got questions, I'm going to try to FaceTime you or Skype with you tomorrow and kind of answer some of these.